There you go. Thanks for reminding me, actually. All right. And then the generic formula for what are we talking about? A exponential growth is going to be a times b to the x power. Where b is the number inside the exponent, while a is the number multiplied to everything. And we'll see how that affects the table sooner or later.
Wait, what is the what type of equation is y equals a times?
That is a exponential equation. Okay.
Oh, I think yeah.
And its reason it's exponential is because the x is in the exponent. That's why it's exponential, because the x is in the exponent.
Jacob, why are you playing with the basketball?
So what we're going to do is go from -2. Shh, don't talk during while I'm talking. We're going to do from -2 to 2. So -2, -1, 0, 1, 2. By the way, when I say domain of -2 to 2, that means from -2 to +2. With that in mind, we're going to take the numbers of the domain and plug it in to find our range. So for the first one, 2 to the -2 power. Again, we don't like negative exponents. So in order to fix that, we take the negative exponent that's on the top, bring it down to the bottom, 1 over 2 to the second power. 1 over 2 to the second power, 1 over 4.
Is it okay if we just write 1?
Try that again.
Is it okay if I just write 1 over 2 to the second power and not 1 over 4? Do we have to simplify?
No, you want to actually get the number. So write 1 over 4, or if you want to do it in the calculator, 1 divided by 2 squared would be 0.25. But at least get me some number. Maybe the decimal will actually be better because we will eventually graph this thing on a like an XY. So graphing it with decimals is easier than graphing it with fractions.
Wait, but
So I would even recommend changing it to a decimal, which is 0.25.
I have a question.
Go ahead.
Say that can we just like, because it's a negative, it's a positive, it's an even negative, so wouldn't it just become positive?
That the exponent is negative. When the exponent is negative, what that does is changes it to the bottom. If the base is negative and then the exponent is positive and even, or actually just even, it doesn't matter if it's positive or negative, then it will cause the whole number to be positive.
Oh, okay, thank you.
No problem. All right, let's go to the next one. I'll change the color so it'll be a little bit more clear. 2 to the -1 power. Again, negative exponents, we bring it down. So that's going to be 1 over 2. Maybe it's easier to put it as a decimal. You could put 0.5 also. Next one, 2 to the 0 power. We need to remember the 0 rule. The 0 rule allows us to make anything into 1. So anything to the 0 power is just 1.
Wait, the y is 1 over 2.5?
No, 1 over 2, or if you wrote it as a decimal, 0.5. The next one, 2 to the 1 power. Anything to the 1 power is just itself. So that's 2. And then 2 to the second power, which is just 2 times 2, happens to be 4. Now what we have is 5 coordinate points from -2 to 2. Now I don't have the tables and I don't have the graphs to send it to you, If I was physically there, I would have it printed out. But basically, your graph would look basically like this. 1, 2, let's make sure it goes up to 4. At -2, it's a quarter or 0.5. And I'll use a different color so it's clear. So that's like barely above 0. At -1, it's half. So that is going to be between 0 and 1. At 0, it's 1. So 0, 1. At 1, it's 2. So 1 right, 2 up. And at 2, it's 4. If we connect the dots, you notice the line is curved. That will happen with an exponential function. So make sure you keep that in mind. The line will be curved in an exponential function.
Should you eliminate the graphing part?
No, get used to it. Get used to graphing. Okay.
Wait, I've
Go
but
ahead.
1/4 isn't on the like. So would it be between 1 and 0? 1/4, right?
Yeah, 1/4 will be 1 to 0. That's why I say maybe just change it to a decimal. 1 divided by 4 is 0.25. And there you could see, oh, 0.25, that's like barely above 0. All right. We're going to do another one. I'm going to do this one also. And then I'm going to give you one to practice, and then we'll go on to the next section. 3 times 4x. This is supposed to be times, so 3 times 4x. You might also see it. Actually, let me draw it like this way with parentheses. There you go. So 3 times 4x. Very important. The exponent is only on the 4 and not on the 3. With the domain of -2 to 2. Typically, unless I specify otherwise, you could assume the domain will be from -2 to 2. Same page. Let's see if it could be a little easier.
So I have a question.
Go ahead.
So for that, would you like multiply like 3 times 4 and then do the exponent?
Oh, say that again.
Like it would be like 12 to the x power.
Close. So yeah, you're getting the right idea though. You would do the exponent first, then multiply. So let's do it together. I wanted to do this one together, and then I'll give you one for your to practice. X 1, 2, 3, 4. Yeah. Okay. So the domain or x values are always are going to typically be the same. So that is x, y, and it's -2, -1, 0, 1, 2. So let's start with -2, which I would argue is probably the hardest one of them. So what we have is 3 times 4 to the -2 power. Once again, since it's a negative exponent, I'm going to bring it down. So it's 3 times 1 over 4 to the +2 power. Now I can rewrite 1 over 4 to the second power as 1 over 16. When I'm multiplying two things like that, I can make this whole number into a fraction and then multiply straight through, which means my final fraction is 3 over 16. If you want to change that to the decimal, it should be about 0.18, something like that, 0.1825, something along those lines.
Can you make a proper fraction instead? Like let's say it would be 5 to the 5 and 1/16, right?
Yeah, you could do an improper fraction or a mixed fraction if that's what you mean, like a mixed number.
Yeah, I meant, yeah.
Yeah, that's fine. Like I said, the decimal is only suggested if you have a hard time visualizing the value of a fraction, because when I ask you to graph it, you got to make sure it's put in the correct place. So you want to be close to that. You don't want to be like a whole unit off. Next one, I'll do in red. 3 times 4 to the -1 power. Again, in this situation, negative powers means bring it down. Since I'm dealing with a fraction, I'll make everything a fraction. So 3/1 times 1/4. Multiply straight through 3/4. 4. 3/4. As a decimal, that's 0.75. Next one, 3 times 4 to the 0 power. Keep in mind, anything to the 0 power becomes 1. But 4 is the only thing to the 0 power, so only the 4 becomes 1. So it's just 3 times 1, which is 3. I know there's a high chance somebody will make the mistake and put a 1 here automatically. Make sure to remember only the 4 is getting raised to the x power. Next one, 3 times 4 to the 1 power. 4 to the 1 power is just 4. So 3 times 4 is 12. And then the last one, 3 times 4 to the 2nd power. That's 3 times 16. 3 times 16 is 48. Now, the general shape of the graph is going to be the same kind of situation. It's just going to be what we call a little sharper or faster. So for the first point, 3/16, that's somewhere between, I should pick a different color. It's somewhere between 0 and 1. 3/4, that's somewhere between 0 and 1, but a little bit higher than 3/16. 0, 3, so 0 and then 3 up. 1, 12, that would be really high. I'm not going to draw the line. You don't need to draw that line. You kind of get the idea. And at 4, 42, 48, that would fall off the graph way hard. So you would just graph this as best as you can. But notice the shape is still the same from the last one, kind of that like ascending hill. All right. Does anyone have any questions on this one? I'll pause it for a second. Okay. If not, everyone try this one. Let me replay this. Okay. So everyone try this one, which is on the bottom. Let me extend the page a little bit. y equals -8 2 to the x power for the domain of -2 to 2. So the domain is the same. Everyone here should be starting off the same way. X, y. And then your x values are the same. What you guys are trying to do is find those y values.
Should we simplify?
If possible, especially for this one, it should be very clean to simplify.
Mr. Tobel,
Yeah,
when it's like, you know how like when it's a negative exponent and we put it to the bottom, we switch the
Yes.
exponent. Do we also switch the normal number?
what do you mean the normal number?
Like the number, like pretend it's -8 and then the exponent's -2. Do we switch
Yeah.
to the -8? We do.
No, only the number with the exponent, so just 2.
Mr. Tobel,
Yeah.
as the numbers get bigger, do I have to like keep on like drawing the graph line all the way down, or can I just like kind of like?
Go to like 8, down 8, and then you'll get the general idea. You just want at least like 3 points to get the general idea. I'll show you how I would do it.
But I don't know like which way to go after. I'm just saying.
They'll
Like,
just
I did it up to 8, and then I have the 1 and 2 one, which is like which are like higher numbers. But like, I don't know. It's like one. I don't want to
Are
like
you
say, I don't want to say the answer, but I did the first 3 points, and I got
Well,
1 to 16. Yeah.
All right. If you look at the board, I have the answers if you need to check it.
But do I have to go all the way down? I'm saying.
No, like if you just wrote, I'll do in blue or in green. If you just wrote this, like if you just
Michael's
wrote
computer died, and he got
green like
black.
that, that's fine. All right. For Michael, I'll post it on Google Classroom anyway. I think someone else
Okay.
is anyway. So Oh, you got back in. All right. Okay.
Wait, how'd you get that swerve kind of thing?
It's always going to have that swerve, whether it's a
My computer.
upward swerve like in the previous one or a downward swerve like this one. So there's always going to be some type of swerve.
But I didn't like really get a swerve. Mine's like kind of like a straight line. A little
Definitely
bit.
should not be a straight line. So check your like numbers here. Don't make it too close to each other, maybe. But it's definitely not a straight line. It's got to be some type of swerve. Okay. So here's your answers. Notice how the -8, what is the line? Notice how the -8 causes it to go downwards, while the other ones, like in the previous, went upwards. This one is going downwards. So we have an idea what A does, and we have an idea what B does. And we're going to talk about both. Does anyone have questions on this one, though?
How did you? I got the first two, but then my computer died, so I couldn't do it. So how did you get the -8?
-8 times 2 to the 0 power. Anything to the 0 power is 1. So -8 times 1 is -8. And I'm gonna show you how you could do this easier after right now, actually. I'm gonna show you.
Is it with a calculator?
No, you could do it by hand. Okay. All right. Is everyone okay if I move on? Do you at least have the answers? If you want to ask me questions, I'm happy to go over a little later, though.
We're starting another lesson.
We're continuing the same lesson. We're going to the next part of the lesson. Okay. So this one right here, guys, if you've been writing your notes, was the second one we did. No need to rewrite this. What I want to do is point out what the A value does and what the B value does and how we could use it to our advantage. Okay. First off, notice what is the pattern. I'll use the whole numbers because it's a little easier to see the pattern. But what's the pattern from 3 to 12 and 12 to 48? Anyone could speak up to see what the pattern is. How do I get from 3 to 12 and then get to
It's like
12 to 48?
multiplying by 4.
Good. Multiplying by 4. Now, where do we see a 4 in the equation? At the
It's
B. Yeah, good. At the B. So we know the B is going to be, I could type this out so it's a little bit neater actually. B is the pattern of growth in terms of multiplication. Kind of similar to how slope is the pattern of growth in a linear equation. B in this case is the pattern of growth in a exponential function. Now over here at the x equals 0, we have the value of 3. Remember, when x equals 0, that is actually your y-intercept. So which one of these gives you the y-intercept? Probably the A value. So while B gives you the pattern of growth, A is the y-intercept. Basically, when x equals 0, it should be A. Y equals A. When x equals 0, y equals A. That is the y-intercept. Now, I promised Shank we have an easier way to do these problems, and I'm going to show you the easier way to do these problems, or at least faster for sure. So we're going to do one more example. Y equals, let's do 4 to the 2x power. We're going to make the domain from 2 to -2. Okay. So x, -2, -1, 0, 1, 2. Now, let's say if I found the first point. So 4 times 2 to the -2 power. That's 4 times 1 over 2 to the second power. 4 over 1 times 1 over 4. 4 over 4 equals 1. So I know I could just put a 1 here. Actually, I shouldn't erase that. I'll keep the work there. So if you start at 1 here, the next step, if the pattern's true, or B is 2, then we're going to multiply it by 2. So our next one is 2. And then we could just repeat it. The next one times it by 2 is 4. The next one times it by 2 is 8. And the next one times it by 2 is 16. So our y values follow the pattern of B. And to check our work to know we did it correctly, we could look at here and see that matches our y-intercept. At 0, it should be 4, and it is 4. So that indicates that we're doing something correct. So you could do it by finding each point individually, or you can do it using the pattern and starting points. So you could use either method to make the table, okay? With that in mind, I think you guys learned a lot today. I'll let you go. Have a wonderful day. I'll post the homework a little later.
Thank you. Have a nice day.
Like multiply.
No problem. If you have any questions, you can stay on if you want to ask.
Can you do this for every single question?
You could do this for every single question, and I just want to go back to show you that's true. Like look at let's talk about this one right here. -2 times it by 2, -4, times it by 2, -8, times it by 2, -16, times it by 2, 32. Or you could look at this one over here, times it by, it was 2 again. So times it by 2. The only thing is fractions might be a little bit harder, but you can still do it. 1/4 over 2 over 1 is 2 over 4, which is 1 over 2. Multiply by 2, multiply by 2. So it's true no matter what. Okay, Shay?
I forgot to do yesterday's homework. I'll do it today.
All right, you got up to the test day.
I did half of it with you in class.
Exactly. So get the other half done then.
Okay, thank you.
No problem, man. Kobe, everything all right? Are you physically there?
Yeah.
Okay. You have any questions for me, man?
No, I'm good.
Okay, man. Have a wonderful day, all right?
All
I'm
right.
gonna
Thank
log
you.
off.
Have a good day.
You too. Bye.